Hello everyone. In this lecture, I will introduce the MATLAB software, and we will learn some basic operations using MATLAB. I will start by creating variables in MATLAB. All variables in MATLAB will be multidimensional arrays, no matter what the data type is. So let's see if let's say I want to create x as a variable, then I need to go like this. So it will create x as a variable, but you can say it as as an array, or you can say it is a matrix with one row and four columns. This is first column, second column, third column, and fourth column. Right. Let's create some more variables. Let's do x equal to 1 comma 2 comma 3 comma 4. If you want to create the second row of the matrix, then we need to say 5 comma 6 comma 7 comma 8, and it will create a matrix of 2 cross 2. We can also create a matrix with all elements as zeros. So let's see z equal to zeros. That's the command. And if I need to pass an argument where I need to specify the size of the matrix. Let's say it's a 5 comma 5 matrix, right? And this creates a matrix with all elements as zeros. Now if I want to create matrix with all ones, let's say z2 is the matrix, z2 equal to ones, right? So that's the command, 5 comma 5. So what you get is or a matrix with all ones, and the size of the matrix is 5 cross 5. And let's say now I want to add 20 into every element of Q, every element of Z2. So what I can do is Z2 plus 20. So what I will get is every element will be added uh, will be added with 20. Now I want to um, let's say I create a matrix Q2 equal to Z Z, and multiply every element will be multiplied with, let's say, 10. So I every so Q2 uh, let me just do it is Q2 equal to Z, right? So Z was the matrix. Okay, Z was 0, so I will have to multiply here with Z2. Z2, okay, Z2 multiplied with 10. So I get every element of the Z2 matrix will be multiplied by 10, right? If I want to say Q2 divided by, let's say, 2, then I will get the result. All elements will be divided by 1, or will be divided by 2, and I'll get the answer. Now let us say I want to create another matrix Q3, which is equal to sine of, let's say, sine of all the, I will get the sine values of all the elements of the Q2. Let's say Q2, then you will get all the sine values you can calculate. You will get. Then let's say I want to generate a magic matrix. Magic matrix is a matrix in which all the rows and columns will have the same sum. So let's say I want to create a magic matrix M, and the command is magic. I need to specify the size, so it generates a square matrix. So this will generate a matrix with rows and columns have the same sum, right? So I have now a matrix M, which is generated by the magic command. Now let's say I want to get the transpose of this matrix. Let's say M uh, transpose equal to tell M, and I will put this comma sign here. Then I will get the column. The first column will become the first row will become the first column, and so on. The second row will become the second column. So this is the transposition of the matrix. I can get the inverse of the matrix also. Let's say I equal to inverse of, let's say I want to get the inverse of matrix M. So I will get the inverse of the matrix also. The values I get is having the values are up to 4 decimal places. Now I can increase the resolution of the values that I will get. That I can do by format command, format long, right? Now if I get the inverse of the matrix, let's say I equal to inverse M. So in that case, I will get the high resolution values. Now, if I have to come back, this is only for the display purpose. In the compute, it will not help in the computation of the. It will not do anything into the computations. All right, the computations will go as per the software set values, right? Now we can come back to the same format by saying format short. So it will come to the same format. Now if I get the inverse of the matrix again, then what I will get is the same resolution values. All right. Now I need to see how to concatenate the matrix, two matrices. Let's say I have a matrix X, right? 3, 4, and I separate the rows by, let me have only 3 columns. So I will, the second row I will create is 4, comma 5, comma 6, then again semicolon, then 7, comma 8, comma 9, and I generate this matrix, 3 cross 3 matrix. And I also generate one more matrix, which is Y equal to ones, um, two ones with 3 comma 3, let's say 3 comma 3. So what I get is, so I need to now do the concatenation of X matrix and Y matrix, and let's say I want to do the horizontal concatenation. How I will do the horizontal concatenation? I will say Z, another new matrix I will create equal to X comma Y. So I will be able to concatenate horizontally, all right, in which the number of rows will remain the same, the columns, number of columns will increase. And now let's say I want to do the vertical concatenation. So vertical concatenation I can do, let's say V equal to bracket starts X, then I need to put the semicolon here, and Y. So I get the vertical concatenation of the matrices. Now, let's say I want to look for the, I want to work with the complex numbers. How can I generate the complex numbers into MATLAB? Let's say X equal to, that I can generate by square root of, if I take the square root of -1, it will generate a complex number. All right. And let's say I generate another complex number, Y equal to square root of -2. Okay, so it generates another complex numbers. And let's say I take third complex number as Z, and I say X plus Y, sorry, Z equal to X plus Y. So I will get the summation of the real part and the imaginary part. Now if you see, this is the workspace, all the variables that I have created will come here, and you will also see the value, the size of these variables created, right? Now if you give the clc command, what it will do, it will clear the command window. If you say clear all, then it will clear the workspace, right? It will clear the workspace. You can now enter new variables. You can use the same variables also. All right, now let us do the array indexing. How the array indexing will be, that means how to accessing array or matrix members at different locations is known as array indexing. Now, how we need to, if we want to access any element in the array, right, or a matrix, then how to do that? So that is known as array indexing. Let us create a matrix. Let us create a matrix with magic command, and this creates the magic matrix, right? If I want to access, let's say, the first row and the fourth column element, so let's say I want to get the value in x equal to, what is my matrix? Matrix is M, and I want to get which element? Let's say first row and the fourth column. So that means I want to go to this. I want to get the value as 8. So I can do it like this. So this is 8, right? And let's say x equal to M. I want to get the second row and first column value. So I will get is 23. All right. And let's say if I want to get V, and um, V equal to M, and I want to get these all the values of the second row. So second row, right? I want to get the values of all the values of second row. So that means so first argument will be 2, which is the second row, comma. I want to get the values starting from first column, and I will put colon here, and I have to go up to 5. So I will get these values, all the values of the second row, and um, all the values of second row are obtained. Now let us say I want to get the values of uh, second row, right? But I want to get from 3 to 5, column 3 to 5. So I can do it like this. 3, earlier I did it for 1 to 5. Now I will do it from 3 to 5, 3 to 5. So I will get 3 values. All right. And now let's say I create another variable v2, and I want to get the values of the fifth column, and I want to get only values from 2 to 4, row 2 to 4, but only for the fifth column. So how I will do? I want to reach to matrix M. That means I want first entry will be for the row. I want to go from row 2 um, to 4 for the fifth column. So I will get these values. All right. So this is how you can access the various locations of the matrix, and this is known as array indexing. Now let us see how to save and load the variables. Now if you type here whos, that will give you all the variables that are there in the workspace and that you have created, and it will give the size of the variable, it will give the number of bytes taken, class, and other attributes it will give, right? So let me uh, let me let me now clear the workspace, right? Before clearing the workspace, because I want to save save these variables. So the command that I will use is save into some file. I will use my variables is the file name, and the extension of that file will be .mat, right? So it will save all the variables in the workspace. Now you can say clear all, right? So it will remove everything from the workspace. right? Then you will have to load this file again to get the access to these variables. Now, how to load the variables, right? Now, if you now let's say what were the variables x, v2, vm. If I type x, so you get an error because it has been removed from the workspace. Now, how to load this variable file back into the workspace? You will have to say load, right, and the file name my variable my var dot mat. So it will load the file again. You will see that the variables will again appear. Now if you say x, that will give you the value. So this is how you can save the variables in the workspace, and you can also load the variables back into the workspace. Okay, let me now clear the command window. Let me also clear the workspace. I want to plot 2D graphs now, right? And for plotting the graphs, I need values. Let me generate the values. Let's say I generate x values along which will be along the x-axis. The x values, let's say the x values range from 0 to 2 into pi, right? But I need to create in between the steps also, and the steps I create are uh, pi divided by 100. So going from 0 to 2 pi and with steps of pi by 100, I generate the x values. So these are the x values generated, and if you see the x values generated here, you will see that these are the x values, and this is in the form of a matrix 1 cross 201. So that's the size of the matrix. All right. Now, if I want to plot these values, if I want to plot a sinusoidal signal, so I need to generate the sinusoidal signal, which I can generate by y equal to sine of x. So that will generate the y values also. Now I need to plot the x and y, sorry, x and y values. So this is the sinusoidal signal generated. All right. So, but if you see, there is no labeling across the x or y axis. So I can do the labeling also. That I can do by plot x comma y. Then I can x label, which is the command x label. I can say these are my x values, right? And I can also say y label. These are my uh, y values, right? And okay, these are my y values. And if you can see in the graph, so along the x-axis you get the x values and the y values. All right, now you can also put a title to the graph with the title command title. Let's say you want to write here sine plot, sine plot, right? So if you say enter, the graph will have a title also, which is the sine plot. This is how you can go with the plotting, and then you can change the color also. Plot here, the color of the graph is blue, which is the default color, but you can change the color also. If you say plot x comma y, right, comma r, and if you enter here, so you will see that the color of the graph is also changed. Like that you can try various options. You can also say plot uh, x comma y comma g. Let's say we want to plot the green color, but we want to do the we want to represent the signal in a dashed form. Right, let's see how it goes. Okay, let's see the signal. The signal gives me the dashed line. So there are various options that you can try while plotting the graphs. Now you can also plot multiple graphs, right? Uh, when you have plotted this graph, you can say hold on will hold the graph. We in the same figure we can draw other graphs also. Let us say I define another signal. Sorry, I define another signal y2, and I say y2 is equal to cos of x, right? So if I say y2 equal to cos of x, so this signal will be generated, and these are the values which I will get for the y2. Now I want to plot the graphs. Plot, I will say plot x comma y2 comma, let's say if I want to plot in red color, right? And so this will come in the same graph only, because I have set the hold on. So it will come in the same graph. Then I can do the I can put the legends also for the graph. Now I will say legend, right? The first legend I can say is sine. Sorry, I can say is sine, and the second legend I can say is cos. And if I do like this, what I will see is that this graph goes for the sine and the red colored graph goes for the cos. So I can put legends also, I can do various options. Right. So this is how I can plot multiple graphs. Now this is regarding the plotting of the graph. You can try the commands. Various commands and options are available, which you can try while writing the MATLAB scripts. Now let us do if in a data set, let me first clear the command window, right, and also clear the workspace. That will clear my workspace. Now I want to deal with the missing data. Let's say you have a database and you want to, and there is some data missing in the database. So how to deal with that? Now, first of all, let us create a data. Let us create data in which some portion of the data is missing. Let me create X, and let's say 1 comma 2 comma 3 comma 4, and uh, this entry I say nan, not a number, so that means this is missing data. And I say this is 6, I say this is 6 7 and 8. Let's say this is my data, right? So this is my missing data, this is not a number. And if I want to let me try to plot it. If I plot x, so what I get is uh, so this is the missing data I have got. So this is about the missing data, because one of the data is missing, right? Now, and also if you want to get the mean of x, so it will not give you the mean of the value because one data is missing. But if you want to, let's say, want to get max of this data, max of x, then it will give you 8. It will give you, but it will not give you any, it will not give you mean, but it will give you max. let's say if you want to get the minimum value of x, then it will also give you the minimum value. But it has not given you the mean. Let's say if it can give variance, so it will not give variance also. Let me see whether it can give standard deviation. Um, so it is not giving the standard deviation also. Now, if I want to check whether some value is missing in the array, then I can use is nan x. Now, if I want to check whether some values are missing in this data or not, so it will give, it's a logical array. So this is not missing, this is not missing, this is not missing. Where one is there, so that value is missing. All right. I can also use the command is missing uh, x. That will also give me the same result. It will put a logical one where the value is missing. Now I want to, if I want to fill the value, right? If I want to fill the missing value, I can say, let me say x2 equal to fill missing, x2 equal to fill missing. So what I will do is, where I have to fill, I have to fill in x. What value I have to fill? I will fill some constant, let's say, right? And let's say that constant is 1. So I'm filling the value missing. I'm filling the missing value in x, and I'm filling it with constant. And so if I run this, and now if I get the, if I want to know what values are there for x2, so you will see that x2 has filled in x2. This missing value has been filled. Now if you want to calculate the mean, you can get the mean now. Okay, so this is the mean. You can get the variance also. Okay, so this is how you can, and you can also remove the missing value. How to remove the missing value in the data set? Let's say I create x3. This is equal to rm missing, right? Missing, remove missing from where? From x. So I can say it like that. So that will remove the value. Now if I say, if I try to get the value x, you will see that the number of values in x3 have been reduced. So there are only 7 values, whereas in x there were 8 values. Now, if you, let's say I want to write the data to a file. All right, how to create a CSV file, comma separated file. The data created in the MATLAB, I want to store it in the CSV format. So let's see how we can do that. Let me clear the command window, and let me also clear again the workspace. Okay, now let us write data generated by MATLAB to a file. That means we want to put the data generated in MATLAB to a txt file, and we will put that file, we will save that file in .csv format. All right. Now let us generate a sine wave, and we will try to put the data into the txt file, into CSV format. Let's say we want to generate sine wave of frequency 20 hertz, and we define the sampling period or sampling period as 1 by 100. Then we define the time interval in which we want to have the sine waves equal to 3 seconds, right? And then we want to create a time vector which will range from 0 to 3, and in between the time steps will be 1 by 100. So that means we want to start from 0 with time steps as t as defined by ts. So we'll go to t, right? And then we want to generate a sine wave. That means y equal to sine of uh, 2 multiplied by, sorry, multiplied by pi multiplied by f multiplied by t, and we close the bracket. And then let's try to plot this signal. Plot t comma y, right? And let's see. So this is the 20 hertz signal generated, right? And we want to, and if you see in the workspace, this is the y vector, and this data is there with 300 columns. This is 1 cross 300. So we want to save this data to the CSV format file, to a file with the CSV format. So to command to create that file is CSV write, right? Then if the file exists, then MATLAB will take the file itself, or we will give the file name. The file name is underscore simple underscore signal dot txt. So that's the file name, right? Comma y. So we want to save in this file the data y. So let's do it, and y will be an array. So this is the file name. Now you will see that uh, the the this is the file created. Now this is the simple, if you see here, this is simple signal.txt file created. Now in the now we will, what we will do is we will read from this file and we will try to generate the signal. All right, so this is the data written. Now let's clear all, right? And we do the CLC clear the command window also. Now let us load the file. We, what we say is signal equal to load, right? Load what? What we will do is we will load this file, load um, underscore simple underscore signal dot txt, right? We will load this file, and let's see. Okay, the file is loaded. So we, what we have done is we have directly read the data which we create, which we stored in the file. Now we are loading the file and we are reading the we are reading it from the file. So this is one way of loading the file. The other way can be, so let's plot the signal. Plot uh, signal. Let's see what comes up. So what we will see that this, the same signal will appear. All right. Now what we will do is we will create another. We will use the second method. We will, what we will do is we will create another signal 2, which is equal to. We will use the CSV read command. We will read the file. First we use the load command. Now we will use the CSV read, and what we have to read, we have to read the file. We need to give the file name, which is simple underscore signal dot txt, and we need to close the bracket, right? So this is the file read. Signal2 file is created. Now let's try to plot uh, signal2, right? And we will see that uh, so this is signal2 is plotted. The same signal is plotted here. All right. Okay. So this is the This is the loading of the um, values of y. All right, so this is how uh, we can read and we can write the files of the data which is generated. This is the signal generated. All right, so this is signal 2. So I finish my lecture here, and this was a kind of an introductory lecture to MATLAB programming. Um, then we will use this programming concepts into our DSP course. Thank you.